section 1.6, page 5, the final page. So now we need to talk about techniques for finding limits that go to positive and negative infinity that not only don't have a denominator, they also don't have a radical. So we're going to have that variable to various exponents. So we're going to focus on the highest valued exponent. In this case, I'm saying n, and its coefficient. So in this case, a. Of course, if m was larger than n, we would focus on that and a coefficient of b. I like to think of plugging a million in if I'm having a function that's headed towards a positive infinity, or I'll plug negative a million in if I have a function that is headed towards negative infinity. And so then basically we're trying to figure out what's happening with that. Would plugging this million value in for x give us a positive or negative output? So these are the same problem. I'm headed towards positive infinity, no denominator, no radicals. So the highest valued exponent is x cubed, and the coefficient of the term with the x cubed is the negative 7. You always need to take what's in front. So if it had been over here, it would be a positive 2, but because I see a negative sign, I need to take that. And in this case, I'm headed towards positive infinity. I have an odd exponent. The coefficient is negative, and I'm thinking of plugging a million in, positive a million. So I've got this negative 7 out front that's always going to stay negative. Then even though I'm plugging a positive number into a cubed exponent, anything cubed won't affect a positive, right? A positive cubed is still positive. So I will end up with a million times negative 7, which would give me negative 7 million. This number is getting crazy small, so we say that the answer is negative infinity. The only reverse, I still have a highest exponent of 3. I still have a coefficient of negative 7 in this case, but now I'm going to negative infinity. So my negative 7 stayed negative. But when I cube, because it's odd, a negative number, I'm going to get a negative result. And a negative times a negative is positive. So I'm not going to have a horizontal asymptote, but as I head to negative infinity, this graph is headed straight up towards positive infinity. So let's recap all that asymptotic information that we've learned. We want to find a vertical asymptote. Then basically we're going to figure out when does the denominator not equal 0 after canceling terms. These are the x values where the function is undefined. Notice your vertical asymptote should always start with x equals, not an ordered pair because it doesn't exist on your graph. For a horizontal asymptote, what we need to do is we've got to take the limit to both negative and positive infinity, and whatever the output is will be our horizontal output asymptote, which will start off with y equals. So think about, where is this landing on the graph? It will always be y equals 2 for a lot of x's. This will only be x equals negative 4 for, doesn't actually hit the graph. Okay, so I'm given example 5. Find the vertical and horizontal asymptotes of this function. Notice there's not a limit in front of it. When I'm asked for the vertical asymptote, I need to figure out where is it undefined. So I'm going to go ahead and factor what I have. I'm going to cancel out any numerator and denominator like factors. This is a hole in the graph. This is something that might look like this, but it's not an asymptote. My function is not defined at x equals 1 in this particular case, but I don't have an asymptote there. Anything that's left, I now focus on when is the denominator equals 0, so I subtract the 4 from both sides to get x equals negative 4 as my only vertical asymptote. But for horizontal, the question didn't have a limit, but I need to take the limit as x goes to positive and negative infinity. What happens here as I find my largest variable exponent in the denominator and divide everything by that. Here it is, each term divided. Here it is simplified. I decided you guys are strong enough now, you don't need to actually physically put the infinity. You know that any number over infinity is just going to go to 0. We get 2 over 1. Now, if I plugged negative infinity, would anything change? No. Changing these to negative infinity does not impact that my final answer is going to be 2 over